Hi Class A, wake up Ian. Like I said last night at the counselor nights, I asked everyone what x squared equals 25 would be. And despite the fact that every single incoming freshman thinks they're a super genius and it's equal to 5, there are actually two possibilities. X could be equal to positive or negative 5. So another one of my favorite things to ask about is something that all of you have heard of, the Pythagorean Theorem. I will go around to juniors and seniors and ask them what is the Pythagorean Theorem. And they will all say a squared plus b squared equals c squared. And I will tell them that they are wrong because they didn't use in a right triangle, which is pretty important. If you ever watched The Wizard of Oz, they actually misquote the Pythagorean Theorem quite famously. So we have to say in a right triangle, a squared plus b squared equals c squared. And furthermore, if we're going to be perfectly correct, we have to define what a, b, and c are. Which means that if we say let a and b equal lengths of legs, in other words, a and b are the legs of the triangle, and c is equal to the hypotenuse, or the length of the hypotenuse. So if I kind of pulled a little triangle out here, it's a random triangle, the hypotenuse is another way of saying the longest side. Every triangle has one side that's going to be longest. If it's an isosceles triangle, where they have two sides of the same length, see, here's an isosceles triangle. Then we can call the hypotenuse any of the two longer sides, or maybe the hypotenuse of a isosceles triangle is the base, or it's the long side here. But in a right triangle, particularly, a right triangle is a triangle that has one right angle, and very clearly, sorry, we're closing email. Very clearly one side is longer, and that would be this side, and the other two sides, A and B, are kind of arbitrary, so what we call A and B. Sometimes we might have an isosceles right triangle. Let me see if I can draw one of those with this tool. Okay, this thing keeps moving. That's close. In an isosceles right triangle, your two legs are the same length. So here's an isosceles right triangle, A and B, but clearly the longer side is easy to identify. So bottom line, if C is the hypotenuse, that means it's the longest side. We're going to practice with some drilling at first, because this deals a lot with square roots. A, B, and C are sides of a right triangle, and I'm going to sketch that out just a little casually with a little right angle symbol. A is equal to 8, B is equal to 6, and C is unknown, and we want to find the missing side here. So what we do is we set up a squared plus b squared equals c squared. And I'm going to substitute. A squared is 8 squared, b squared is 6 squared, and c squared is unknown still. The order of operations says that you do the groupings first, and then we do the exponents. 8 to the second power is 64, 6 to the second power is 36. That's equal c squared. Then we add. 64 plus 36 is 100. And c squared is equal to 100. If c squared is equal to 100, c is equal to the plus or minus 10. However, since this is a side length, we have to reject negative 10. And so we're just going to say c is equal to positive 10. As a scientist, I have a problem with this problem having no units, but for now I guess it's okay because we're just practicing drilling. Another thing to keep in mind is that this created 8, 6, and 10, which is called a Pythagorean triple. Pythagorean triples are integer values for a, b, and c that work, where a squared plus b squared equals c squared. Somewhere, let's kind of list off some other ones. 6, 8, and 10 is actually a variation of 3, 4, and 5, because 3 squared plus 4 squared is equal to 5 squared. There are some other ones. One that comes off the top of my head right now is 9, 24, and 25. Okay, two others. We have 8, 15, 17. Is that it?
Yes.
Yeah, 8, 15, and 17 work. And then another triple that works is 5, 12, and 13. So you don't have to memorize these because you can always do Pythagorean theorem, but it's just helpful to know that these or any multiples of these will always work. Okay, let's go to number 2. I have 9 and 11. If I draw a right triangle, A is 9, C is 11, and we have an unknown. Unknown is B. So since A squared plus B squared is equal to C squared, and I substitute, I get 9 squared plus B squared is equal to 11 squared. 9 squared is 81, plus B squared is equal to 11 squared is 121. Subtract 81 from both sides, B squared is equal to 40, and this means that B is equal to the positive square root of 40, which we want to simplify. 40 can be made to be 4 times 10, so that simplifies into 2 times the square root of 10. Flip it around to the next problem. I've got, let's see, A is radical 7, B is equal to 2 times the square root of 5, and C is unknown. So then I do A squared plus B squared is equal to C squared. A squared is the square root of 7 squared. B squared is 2 radical 5 squared. And C squared is unknown. Well, the square root of 7 squared is just 7. 2 radical 5 squared. 2 squared is 4. Radical 5 squared is 5. Equals C squared. 7 plus 20 is 27. So I have C is equal to the square root of 27. Which can break up into the square root of 9 times 3, or 3 times the square root of 3. Some more examples. This one says find y. It's just kind of a little image, the kind that you might see on a standardized test or something. And if I say, well, A is 2 radical 3, B is y, and C is 4, then I can do A squared plus B squared is equal to C squared. And say that 2 radical 3 quantity squared plus y squared is equal to 4 squared. We're going to solve for y. 2 radical 3 squared is 2 squared times radical 3 squared is 3 plus y squared equals 16. This is 4 times 3, so 12 plus y squared is equal to 16, or y squared is equal to 4, which means that y is equal to 2. Again, we reject negative 2, because you can't have a negative side length of an image, at least not in this universe. And a square whose side length is 7 radical 2 centimeters. Ooh, okay, so let's draw a square. That's a bad square. That's a bad square. That's a better square. Side length is 7 times the square root of 2 centimeters. What is the length of each diagonal? Well, this thing keeps moving. Here's a diagonal. And basically what I have is a triangle here, because a square has the same side length on all the sides, and each half of the square forms a right triangle, with a hypotenuse of the triangle as the diagonal of the rectangle. So we're going to say 7 radical 2 quantity squared plus 7 radical 2 quantity squared is equal to c squared. 7 squared is 49 times 2, radical 2 squared is 2, plus another 49 times 2 is equal to c squared. 49 times 2 is 98. 98 times 2 is 196. So I have c squared is equal to 196. Duncan, if we need to factor or break down what 196 square rooted is, we can probably do it a little bit easier than just kind of continually dividing by 2. So 196 I know is divisible by, well, 49. Because if I break it down, 196 is 49 times 4, and then I see it's actually a perfect square. I can always break it down like this and say, well, the square root of 49 is 7, the square root of 4 is 2, and 7 times 2 is 14. 196 is actually 14 squared. Remember back when we learned all the different squares, we learned that 169 was a square, because that's a funny number for some unknown reason. And 169, if I reverse the 6 and the 9, 96 is also a perfect square, which is less of a funny number. A rectangle has dimensions of 9 by 12 meters. The next problem is a rectangle has dimensions of 9 meters by 12 meters. What is the length of each diagonal? Well, if I draw a rectangle, and then I draw a diagonal to that rectangle.
Is there only supposed to be 2 problems?
What is the length of each diagonal? So we first draw a diagonal here. That looks a little bit better than that. Sorry, I lost myself. Okay, got the diagonal. If it's 9 by 12, then we have an unknown diagonal length c. And so clearly you should be able to see that we have a right triangle here, and we're going to relate that with 9 squared plus 12 squared is equal to c squared. 9 squared is 81, 12 squared is 144, and 81 plus 144 is 225. 225, square root of 225 is 15, so c is equal to 15 meters. Now, if any time that you have like perfection like that, this was 9, 12, and 15, we're going to look at that and reduce that down and see that that was actually 3, 4, and 5, but times 3. That was one of the Pythagorean triples we talked about earlier. Number 7, the side lengths of a triangle are radical 3 picometers, 4 radical 3 picometers, and 3 radical 5 picometers. Show that the triangle is right. First, we have to know which one of these 3 is biggest. Radical 3 is approximately 1.7. 4 radical 3 is like 4 times that. And 3 radical 5 is different. So let's pull out a calculator real quick and kind of plug in and see, is 4 radical 3 or 3 radical 5 bigger? So if I pull this up, we can see that 3 radical 5 was smaller than 4 radical 3. 4 radical 3 is the biggest. So if we're going to call one of them c, that would have to be 4 radical 3. So I'm going to do a squared plus b squared equals c squared. We'll call this a, and we'll call that b. So I have radical 3 squared plus 3 radical 5 squared equals 4 radical 3 squared. And what we're trying to do is just see, is this true? S dot. Radical 3 squared. Mother, seriously? So that was a fire drill, and now it's a passing period. I don't know if I'm going to finish this, but
I thought it was like a real thing.
I'm talking to them. Radical 3 squared is 3. 3 squared is 9. Radical 5 squared is 5. 4 squared is 16. Radical 3 squared is 3. Is 3 plus 9 times 5 equal to 16 times 3? Well, since they're both 48, yes. And so that I'm going to write QED, which means quod erat demonstratum, thus it is shown. Show that the triangle is right. The fact that this is true means it is a right triangle. Okay, number 8. A wire runs from the top of the 6-meter telephone pole to the point in the ground that is 6 meters from the base of the pole. Or, sorry, x meters from the base of the pole. The wire is 6.26 meters long. What is x? X squared plus 6 squared is equal to 6.26 squared. You should see that this is a right triangle. We're going to use a calculator for this one. X squared is equal to, I'm going to make 6.26 squared minus 6 squared. And watch, I'm going to do this all at once. I'm going to do a square root over the whole thing. 6.26 squared minus 6 squared, so that when I plug it into the calculator, I can plug it in all as one expression. Radical 6.26 squared minus 6 squared, square rooted, 1.78. So go 1.78 meters to L minus or plus 24 and L minus 18, which means L is equal to negative 24 or L is equal to 18. And this can't work, so we know that the legs are 18 meters and 24 meters. Finally, we know the perimeter of a right triangle is 200 inches. That's the distance all around. The length of the hypotenuse is 85 inches, as we have A and B. So this is, I know that A squared plus B squared equals 85, and if the perimeter is 200, I know that A plus B plus 85 is equal to 200. Let's do a substitution on this. A plus B is equal to 115. That means that B is equal to 115 minus A. And if I take that and I plug it in here, I'm going to get A squared plus 115 minus A squared is equal to 85. Sorry, this should be squared, 85 squared. So continue, a squared plus, let's do 115 squared, 13225, minus 230a plus a squared is equal to, and 85 squared is 7225. So then I have 2a squared minus 230a equals, and if I subtract, I get, that'd be minus 6,000, or plus 6,000. Divide by 2, a squared minus 115a plus 3,000 equals 0. Let's see if I can do this really quick. Let's try 30 and 100 won't work. Yeah, I'm going to put this pause.